Okay, so today we're going to finish up section 1.4. Again, please slow me down because I do tend to talk fast and write fast. So this is continued. This is day 2. Now, what we did yesterday is solved all kinds of equations that had radicals in it today. We have 2 other types of equations to tackle today. So one of the types, we're going to use substitution. So we're going to solve equations using substitution. And these should be very similar to what you'll see on the homework tonight. And so our first example, we're going to come in and solve 2x to the 4th minus 5x squared minus 12 is equal to 0. So as I stated yesterday, one of the reasons you like algebra in general is that I can always write some steps out for you. So what we want to make a note is how we know this is a substitution problem. So the first thing we're going to note is that it's got 3 terms, and then it's equal to 0. So that makes it look like a quadratic. It's got 3 terms equal to 0. Additionally, the middle exponent, whatever it is, and it'll look kind of ugly sometimes, is half of the first exponent. And that's your clue to use substitution. So the middle exponent is always going to be half of the first exponent. So for our particular example, our middle exponent is a 2, which sure enough is half of 4. So those 2 things together are telling me to use substitution. You'll notice it's also in descending order. That means the largest exponent is first, then the next largest exponent, and the smallest exponent is written last. So what we're going to do is our very first step is we're going to come in and we're going to let u equal the middle variable and the exponent on it. So whatever the middle variable is and its exponent is going to be our u. So in our example, and it's kind of scratch work, we're going to come in and let u equal x squared. So u is equal to x squared because that's what's on the middle term. By default, u squared will be the first variable and its exponent. And that's always going to happen. These are what I call canned problems, so no matter what, they fit this template. So again, u is going to be the middle variable, whatever's in the middle of it, and its exponent. And then by default, u squared is going to be the first variable and its exponent. So what we're trying to do is take something that's ugly and make it into something that we can deal with, or is it easier to deal with? Okay, so now what we're going to do is substitute. So step 2, we're going to place in the u's, or substitute. So the coefficients are going to stay there. All we're doing is replacing the x's with some u's. So in place of the x to the 4th, we're going to have a u squared. We're going to keep the 5 with the negative. In place of the x squared, we're going to write a u, and then minus 12 equals 0. So we end up with 2u squared minus 5u minus 12 is equal to 0. And any question on that? Did we see what we did? Okay, once we've done that, our next step is to go ahead and factor. So step 3 is to factor. If it does not factor, I would use the quadratic formula, but for the most part, they are factorable. Factoring is probably where you guys are a little weak. You can take it to the quadratic formula. It will just take more time. I'm going to look and notice that 2 times 12 is 24. I'm looking for factors of 24 that subtract to 5. So factors of 24 that subtract to 5 are 8 and 3. So that means I need to get a 2 times a 4 to get an 8, and a 1 times a 3 to get the 3. And then I'll put my u's in. And then because the larger factor has to give me a minus, I'll put the negative on the 4 and a positive on the 3. Again, if your factoring is rusty, you just need to let me know and we can work on that sometimes also. Let's go ahead and solve. So that'll give me 2u plus 3 is equal to 0, and u minus 4 is equal to 0. Or 2u equals a negative 3, and u equals a negative 3/2. From the other equation, we'll just move the 4 over and get u equals 4. So we've solved it for u, but the question's asking us to find a variable for x. So once you're done factoring it and solving, you're going to unsubstitute. So step 4 is to come in and unsubstitute. I'm not even sure that's a technical word, but we're going to use it. We'll unsubstitute. So that means take the u out and put the x back in. So x squared is equal to negative 3/2, and x squared is equal to 4. Okay, now your book's directions are asking us to find the real solutions. So they don't want any i's in this particular problem. So when I go to square root and solve for x on that first one, I'll be taking the square root of a negative number, which gives me no solution. On the other one, we can go ahead and square root both sides, and x is going to be equal to plus or minus 2. So when I only get 2 answers, a positive 2 and a negative 2. Again, the other solutions are complex. They involve i's, which is not what the textbook is looking for. Okay, let's walk back through that again, just to make sure we're all on board. It's a substitution problem because we see 3 terms equal to 0. We notice that the middle exponent is half of the first exponent. Our first step is to substitute. So we took the x squared and made it into a u. By default, that means that the first term is going to be a u squared. You can then factor that once you've substituted, solve each of those factors, and then unsubstitute by putting the x back in and then solve again. So they're kind of long-winded, but they shouldn't be as bad as last night's homework. So, okay, any comments or questions on the first example? We're going to do several more because there's variations on that theme. So, okay, I'm going to assume that we're good, and I'm going to erase. Let's go do another one. I'm going to rewrite the steps again so that they're a little bit neater over on the side as we go through another one. So this time we want to solve x to the 6th. So we're going to solve, and we need to find all real solutions. So x to the 6th minus 7x cubed minus 8 is equal to 0. So x to the 6th minus 7x to the 3rd minus 8 is equal to 0. Okay. So again, it's a substitution problem. We're going to see the same thing again, that middle exponent of 3 is half the first exponent of 6. It's 3 terms equal to 0. So the first step is to come in and to substitute. So we'll take out the x's and rewrite that as u squared minus 7u minus 8 is equal to 0. And the whole point of that is to get it to a quadratic that's easier to deal with. So at that point, we're going to come in, factor, and solve. Okay, this time we're looking for factors of 8 that subtract to 7. So that would be u minus 8 and u plus 1. Again, factors of 8 that subtract to 7 are 8 and 1. We're going to give the negative to the 8 because it's the larger of the 2 factors, so that when I FOIL that back out, I would get the minus 7u in the middle. Solving each of those, we get u minus 8 equals 0, u plus 1 equals 0. So we'll get u equals 8 and u equals a negative 1. But we're not done because we need x, not u. So the next step is to unsubstitute. So we're going to take out the u and put in the x cubed, which is what we originally took out in the beginning. So we get x cubed equal to 8, and x cubed is equal to -1. Okay, because we're looking for only the real solutions, we can go ahead and just cube root both sides to solve each of those. Cubed root of 8 is 2, and the cubed root of a -1 is a -1. So we get 2 solutions. If you plug them back in and check them, you'll see that they work. That one was much easier than the last one because the factoring was quicker. Again, only because they're looking for the real solutions can I come in and cube root. If I were looking for all the solutions, I would have to move the 8 over and factor it using the difference or sum of cubes, which luckily for us, we don't have to tackle right now. Okay, so that one worked out pretty good. We get 2 answers. There's no way to predict the number of answers. So unsubstitute, and then the last step is to solve again. Anybody have any comments on that one?
Makes sense.
Yay! Comments are good. Okay, let's try another one. Now they're going to start looking a little different. So just to be different, let's say we have x to the -2 minus x to the -1 minus 6 is equal to 0. So x raised to the -2 power minus x raised to the -1 power minus the 6 is equal to 0. Well, okay, it looks a lot different than the last two, but we're going to notice the same thing. We're going to notice that that -1 is half of the first exponent of -2. So for us, we're going to come in and let u equal the x to the -1. That's the middle exponent. So by default, without even stressing about it, I know the first term is going to be u squared minus u minus 6 is equal to 0. So I've taken the ugly stuff out, put in nice stuff to deal with. Okay, let's go ahead and factor it. This time we're looking for factors of 6 that subtract to 1. So factors of 6 that subtract to 1 are 2 and 3. So I'll get a u with a 2 and a u with a 3. Because the larger factor has a negative on it to give us the minus u, we'll put the negative on the 3 and the positive on the 2. Anytime you're subtracting to get to the middle, this sign is what's telling me that I'm subtracting to get to the middle. So I know that the larger number has to take the first sign. The smaller factor takes the opposite sign because we're subtracting. Solving those, we're going to get a u equal to 3, and we're going to get a u equal to -2. Okay, and then we'll unsubstitute. So we're going to come back up here and pull up that. We're going to take out the u and rewrite it as x to the -1, and x to the -1 equals 2, -2. Okay, well now what do we do with that? Well, we got to remember what that negative exponent means. So as a reminder that when you have x to the -n power, it really means 1 over x to the nth power. So in other words, you move it to the layer that it's not on. If it's in the numerator, you move it to the denominator and vice versa. So that x to the -1 really means 1 over x. So we have 1 over x is equal to a +3. And 1 over x is equal to a -2. Notice I didn't do anything with the signs of the 3 and the -2. So all I did is I cleaned up the negative exponent by rewriting it. Well, now how are we going to solve those? Well, what I like to do is cross multiply. So I'm going to put the 3 over a 1 to make it into a fraction. And then we'll cross multiply. So we're going to take 1 times 1 and set that equal to 3 times the x. So top right times the bottom left. That's equal to the top right times the bottom left. So then we'll solve that and see that x is equal to 1/3. Okay, now if you look at what we started with, we had 1 over x equals 3. We ended up with x over 1/3. So can you see that we just reciprocated both sides? You can do that anytime it's a fraction equal to a fraction. If we had more terms, we couldn't do that. So I can do the same thing on the other side. I'm just going to reciprocate both sides. I'm going to flip both sides. So that means x is equal to a -1/2. So I get 2 solutions, a -1/2 and a +1/3. So much different. I really like this one for some reason. I'm not really sure why, but it appeals to me. I think it's a lot easier than some of the other ones that are in this section. Okay, any comments or questions about that? We're still following the same 4 steps. We substituted, we factored and solved, we unsubstituted, and then we solved again. Okay, let's do another one just to show you the variety. Everybody good with that?
Yes.
Woohoo, yay. I hope my pace is better today. If we were meeting face to face, I always apologize on the first day because I tend to talk too fast when I'm nervous and meeting new people. So, okay, let's do another ugly one. How about 3x to the 1/2 plus 5x to the 1/4 plus 2 is equal to 0. Okay, so we look at that and you immediately panic. No panicking allowed. What you're going to notice again is the same thing is true. We have 3 terms. The middle exponent is, yes, indeed, half of the first. That tells me to use my substitution. So we're going to come in and let u equal the x to the 1/4, the middle exponent and its variable. So by default, that x to the 1/2 becomes my u squared. I have plus 5u plus 2 is equal to 0. So now it's no longer ugly. And now we need to factor that. So 3 times 2 is 6. Factors of 6 that add to 5 are 3 and 2. So we're going to do a 3u and a u. Because I want to add to 5, I'm going to put a 1 on the opposite of the 3. I'll put a 2 in the middle. So that gives me a 3u and a 2u to get the 5u because we're adding, they're both pluses. Again, if you struggle with factoring, you can go to YouTube. You can send me an email. I've got some handouts. It's in actually the review chapter of the ebook. If you want to go look for it. Let's solve each of those. 3u plus 2 equals 0. So 3u equals a -2, and u equals a -2/3. Over here, u plus 1 equals 0. So u equals a -1. Okay, now we're going to unsubstitute. So we'll go back to what we said the substitution was. That was the x to the 1/4. So x to the 1/4 is equal to -2/3. And x to the 1/4 is equal to -1. Okay, now from yesterday, if you'll remember, we talked about fractional exponents. We know that a fractional exponent means the same thing as a root. So this is the 4th root of x equals a -2/3. And the 4th root of x equals a -1. Now I need to solve both of those. I need to be very careful here because we are looking for real solutions. Notice that this says the 4th root of a number is equal to a negative. Well, you can't take the 4th root and end up with a negative. So both of these actually stop and there are no solutions. I agree that I could raise both sides to the 4th power, but then if I try and check it, it's not going to work. So again, the 4th root can never equal a negative number. Neither can the square root. So we were fine. Everything worked until the very, very end. And when we unsubstitute is where we discovered that there was an issue. So, hey, how's everybody doing? Good, I hope. Okay, do we need another substitution or do we feel good with those?
I'm okay.
Rick's okay. Yeah, I'm calling you Rick and it's Rich. I'm sorry about that. Part of that's my eyesight. I can't read that tiny little print.
So just to be clear, since it was a even exponent, that's
Correct.
why it's okay.
Yeah. So if I had switched to the original problem and put a negative right here, that would have made this a negative, that would have made this a negative, and back over here, that would have made this a positive, and this a positive, in which case you would raise both sides to the 4th power. So if we'd had just a little bit different sign to begin with, we would come in and raise both sides to the 4th power, and we could keep going with it. So 2 to the 4th power is 16, 3 to the 4th power is 81. Same thing over here, I'd raise both sides to the 4th power, and that would give me a 1. So I would get an answer there, but because it's an even root of a negative, it does not work. Yep.
Okay.
So, yeah, there are lots of sneaky little things that are going to come out of that woodwork tonight when you go to do this second part of the section 1.4. So, okay, well, let's switch gears now. We've done some substitutions. The other problems that are in that section involve factoring with more terms. So we're going to factor And mainly we're going to use grouping. So this is one of those factoring skills that you either remember doing or you've never done it before. So I want to make sure everybody can do it. So the first one we're going to do is x to the third minus 3x squared minus x plus 3 is equal to 0. So what you'll notice, we've switched gears. We no longer have 3 terms and we have extra terms, right? So you can use grouping anytime you have 4 terms, which is what we've got going on here. You want to make sure that it's set equal to 0 in descending order. So the standard form says that it's equal to 0 in descending order. So if it's not equal to 0, move everything over, make sure it's in descending order that you do it. Okay, so to actually do the grouping, here's the steps we're going to follow this time. We're going to split the problem in half. So we're going to cut in half. And literally what I like to do is to draw a little squiggly line that puts 2 terms and then the next 2 terms. That's my cutting it in half. I want to factor the first half. So factor first half. So the first half is the x to the third minus the 3x squared. We want to pull anything out that we can. Well, both of those terms have an x squared in common. That's going to leave me with x minus 3. I want you to bring down the middle sign. Bring down the middle sign. Okay. So for us, the middle sign is a negative. So I'm going to bring whatever that sign is straight down. Then we're going to factor the second half. So we'll factor the second half. So that's the x plus 3. Well, they have nothing in common, but I need a placeholder. So I'm going to factor out a 1. So what we're really doing is pulling out a negative 1. So negative x divided by negative 1 gives me a positive x. Positive 3 divided by the negative 1 we're pulling out makes that into a negative 3. So we switch that sign on the inside. If you don't believe me, all you have to do is distribute that negative 1 back in. So you can pull it back in and you'll get the line above that. Okay, what you should notice right here is that the 2 parentheses are the same. So note the parentheses are the same, which is what we're after because that's what I'm going to pull out next. So because the x minus 3 appears in both the front half and the second half, I can factor out that x minus 3. So when I pull the x minus 3 out of the first half, I'm left with an x squared. When I pull the x minus 3 from the second half, I'm left with an x minus 1. So we just factor that by grouping. Okay, each of those factors can set equal to 0. So at this point in step 5, we're going to say solve each factor. And what we mean by factor is each set of parentheses. So we'll set the x minus 3 equal to 0. We'll set the x squared minus 1 equal to 0 and solve both of those. So we see x is equal to 3 from the first one. We'll get x squared equals 1. We'll square root both sides to get rid of the square. And we need to remember to add in that plus or minus when we're square rooting. And the square root of 1 is 1. So I didn't need that. So we get x equals plus or minus 1. So we get 2 solutions, the positive 3 and the plus or minus 1. So you can check all of them if you want. You can plug them back in one at a time. So plug the 3 in for all the x's. You'll see that 0 equals 0. Plug in a positive 1 for all the x's and plug in the negative 1 for all the x's. So, yeah. And that's grouping. Have you done grouping before?
Yes.
Yeah.
Rich has, Adam has.
It seems familiar, but it's been a while.
Yeah. I can understand that too. Believe it or not, I had never seen grouping until the first time I went to teach an intermediate algebra class. It's like, wow, I didn't know this one. Okay, let's try another one just to make sure everybody can do it. We have 3x cubed plus 12x equals 5x squared plus 20. So I notice that I've got my 4 terms again. That's what's telling me to use grouping. But however, this time they're not equal to 0. So we need to go ahead and move everything to the left side and set it equal to 0. So that means to subtract the 5x squared and to subtract the 20. And then make sure we put it in descending order. So we'll have a 3x cubed minus the 5x squared plus the 12x, and then minus 20 is equal to 0. So there it is in our descending order. So descending order means those exponents are counting down, which they do. Okay, I'm going to cut it in half again. And then what can we pull out of the first half? Well, the 3x cubed and the 5x squared have an x squared in common. That's going to leave me with 3x minus 5. I'll bring down the sign, which in this case is a plus. Again, that's that middle sign coming straight down. And what about the 12x and the 20? What do they have in common? Well, I can pull out a 2, but I like to be greedy. So we're going to pull out a 4, pull out as much as possible. So 12x divided by 4 is going to leave us with 3x. Negative 20 divided by that 4 leaves me with my minus 5 equal to 0. And if we've done it correctly, those two sets of parentheses are the same. And if they're not, you've messed up somewhere. So you need to go back and make sure your signs are correct. Make sure you pull out as much as possible, but they will be the same at this point. So I'm going to end up with a 3x minus 5 pulled out in front. Left over is an x squared plus 4. Again, that's this x squared and this plus 4 written as a factor. So we factored, we're now going to solve each factor. So we'll set 3x minus 5 equal to 0 and x squared plus 4 equal to 0. So 3x equals 5 and x is equal to 5/3. So there's one solution. If I do this one, I get x squared equals a negative 4. When I go to square root this one, I'd end up with plus or minus, and the square root of a negative 4 is 2i. But because the directions are going to ask you to find all real solutions, these two, the plus or minus 2i, are not going to work. There'll be a no solution. So we only get the one answer of 5/3. So make sure you read the directions carefully. In this section, they want all real solutions, so which is why these guys are no good. But it's nice to see one of those every now and then. Okay. Woohoo, there's 2 examples of grouping. Any problems with that? I got one more problem I want to work. Also thrown in at the end of section 1.4 are just some general factoring questions. So let's do one of those. So this is not a substitution problem. It's also not a grouping problem. We'll show you why. So let's solve. Again, we're going to find the real solutions of x cubed plus 2x, I'm sorry, plus x squared minus 20x is equal to 0. So x to the third plus x squared minus 20x equals 0. Okay, so just to make sure everybody understands, it's not a substitution problem because first of all, I might have my 3 terms, but the middle exponent of 2 is not half of 3, so not substitution. It's not grouping because we only have 3 terms. So we just want to factor it. What we're going to notice is that every single term has got an x in it. So let's go ahead and factor out that x. That'll leave us with x squared plus x minus 20 equal to 0. Going to leave the x out in front by itself. Let's factor what's on the inside. It's a quadratic now, meaning an x squared. So factors of 20 that subtract to 1 are 5 and 4. So that's going to factor into an x with a 5 and an x with a 4. Because the larger factor is the 5 is positive, we're going to make that a +5 and a -4. Now we have 3 factors. You just set each factor equal to 0. So x equals 0. X plus 5 is 0. That's going to give me a -5 as a solution. X minus 4 is 0, which is going to give me x equal to 4. So I get 3 answers, a 0, a -5, and a 4. Technically, the MyLab math homework should not care in what order you enter those. If it seems to, you want to put them in numerical order, starting with the smallest number. So if I were listing them, I would need a -5, 0, 4. And I think it automatically puts the squiggly braces there for you, but it shouldn't care which one. Just so you know that it's been my experience using the MyLab math on both quizzes and exams that I need to go back in and give partial credit, because if you inadvertently put them in the wrong order and it's not happy about it, it marks it all wrong. So I would go back in and give you full credit even if they're not in the order that the book, that the program wants it in. So, okay, and that wraps up section 1.4 for us. Tomorrow we'll do section 1.5. Again, we're going to meet at 9 o'clock in the morning. I'll set up that time here in a few minutes and then get that sent out to everybody by email, and I'll posted it onto Blackboard. Does anybody have any other questions or comments?
I had a question from last night's homework just to shore up, because I wasn't really satisfied with how I got my answer. But
Okay, what do you got?
so we had in parentheses 2 times the root of x plus 6, and then all that squared, and then the answer we got was 4x plus 24. I'm just not sure, I'm not confident, I should say, on how we got there.
Okay, got it. So what really matters when you're doing these radicals is how it's written and how many terms you have. So let me rewrite that. So if I have 2 times the square root of x plus 6, and I want to square that, because there is no sign between the number and the radical, I can square everything. So it's considered to be a single term. You can just square everything. So the 2 squared would be 4. The radical squared would be x plus 6. And then in the next step, I would come in and distribute and get 4x plus 24. Now, if you had 2 plus the square root of x plus 6, and I wanted to square that, because there is a sign there, I would have to FOIL that out. And when I FOIL it out, I'd end up with 4 plus 2 times that square root. That would be the outside. I'd get another one of those from the inside. And then when I square the radical, I get just x plus 6. So it all comes down to whether there's a sign between them or not. No sign, you just square everything and then distribute. If there is a sign, you have to FOIL it out.
Okay.
Does that help clean that up?
Yes.
Okay. Please, yes. Always ask. You'll get a lot more out of it and you'll get your money's worth that way. So, okay, anybody else have any other questions? Okay, well, if you're good to go, you can go ahead and sign off. I'll stop the recording now, and then I'll upload the link. Well, I'll upload the recording to YouTube, and then I'll put the link on Blackboard for everybody in case they need it, okay? Have a great day. Enjoy it.
Have a good one.